It'll make more sense if I do it geometrically. All right, look at that one right there. All right, here we go. Where's my sign-in sheet? Where did that go? Where's that folder? Oh, there it is. We're just going to go in order today. Now, if you go by a different name than is on my roster, then I will. I'll change it on here. Just let me know. Umberto, how you doing, sir? Good. So I'm going to ask you the first question. All right. If this is the function f, then first thing I'm going to ask here, what is f of 2? Can you tell? 8. Okay, so that's just algebra, right? That's just an algebra question. What's f of 2? All right, we're good? Next question is going to be for, I'm just going in order, Juliana. How you been? Good, yeah? My question to you is this. So you get the new notation, right? So when you look at that, what are you thinking? Left limit, okay, so take a look at that graph. I want you to approach 2 from the left and tell me where the function's headed. So here's 2, right? Just imagine a vertical line through here. Ignore all this shit that's happening in here, right? And just come in, walk along the function from the left and tell me where you're headed. 8. Everyone got that? Anyone have a question? No? Right, who's up? Edgar? Okay, Edgar, everything all right? Okay, you get this one. What does that mean, Edgar? Coming from the right. So I'll cover it, right? We're coming into 2 from the right. I'm going to cover it up. What do you got? Heads towards 4, right? You'll see that. We come up, come back down, it's headed towards 4. It doesn't, we don't need to ever get to 4, right? It's getting close to 4. The fact that this is an open circle has no impact on the answer. We're headed towards 4. See, isn't it a weird thing, this idea of a limit? It's not exact. It's an idea of getting close to something. Anyone have a question on that? No?
Not yet.
Okay. Enrique. How you doing? Doing good? All right, you get this one. Limit. So, Enrique, what does that mean to you? Do you have any way you can help us interpret what this is asking? How do you mean? I'm not sure I understand. You have to check from both sides, right? Okay, and what is it from the left side? And what is it from the right? 4. Those aren't the same answers, right? In order for this limit to have an answer, what's happening on the left and right have to be the same. Since these are not the same, this limit, how do we say it's messed up? With limits, we don't say undefined. We say does not exist. We say this limit does not exist. And you will see me write D, N, E from now on. That's not a 0, that's D. Does not exist. Reserve undefined for when you're doing algebra and you're trying to plug a number into something and it gives you like division by 0. That's when you say undefined. Only use does not exist when we're talking about a limit where you get something that it doesn't actually crank anything out. You don't get an answer. All right, so recap. Algebra, what's happening at 2? 8. Calculus, what happens as we approach 2 from the left? It's headed towards 8. Calculus, what happens as we approach 2 from the right? It's headed towards 4. Calculus, what happens as we approach 2? Which means we have to look both sides. They're not the same. Limit doesn't exist. All right? New problem. I like calling on people. It's fun. Okay, Jenna. Where's Jenna? I'll probably have a hard time with your names, learning names. I'm not good with names, just never have been. But I'll give it my best shot. Jenna, you're up. Yes? Okay, I'm going to ask you, Jenna. You get the algebra question. So what's f of 2 from this picture? 8. And Jenna, you seem like you're on top of this, so I'm going to ask you another one. What's the limit as x approaches 2? I put a little negative sign of this function. Can you tell me first, like in words, what you're doing?
Starting from the left-hand side, the line is approaching the number 8.
Yeah, so if we're going towards 2, and we're coming in, heading towards 8. Everyone see that? That's rain. It's either rain or an airplane. Limit x approaches 2 with a little plus sign.
Are we able to open up the window?
We can. Do you want to see the rain? Would it make you feel good? Okay. Gabriella, where's Gabriella? Okay, Gabriella, are you following along here? Okay, you get the next one. I'm going to go open the window. It's also approaching 8. It's probably an airplane. Aww. Should we take a field trip? Should we go outside?
Yes.
Yeah. Go play in the rain. There you go. 8. Okay, everyone see that from the right? It's 8 as well? Right, it's headed to the same place. Yes? Okay. Limit x approaches 2. This time I'm not putting plus or minus. And we've got Jaden. Okay, Jaden, good? Understand what that's asking? Yes. What do you got? 8, right? So the answer is 8 here. Why? Because the left and the right are the same this time, right? So we get 8. I'm going to make one up. What do I want? I'm going to go back up to one we did earlier. Was it this one? Yeah, it was this one. Take a look there. Do you all understand that the fact that we're approaching 2 has just been, I've just been using that. It could be any number we're approaching, right? It could have been 3. Or just for these examples, I've just stuck with 2 to keep it consistent. Wait, Jasmine? Jasmine, right? Okay. Okay, that's going to be change here. So let's see. All right, so I'm going to ask you first, what's f of 2 while you're... 6. Everyone see that? At 2, right? That's the algebra question. F of 2 is 6. Do you want to keep going? Okay. What's the limit as x approaches 2 from the left of that function, Jackson? 8, right? So we cover this up. We come in from the left. We're headed to 8. How about from the right? Want to keep going? Yeah? 4. Right? And then finally, what's the limit as x approaches 2 without me telling you left or right? That would be D, N, E. Does not exist. Why? These two aren't the same. They have to be the same. It's over? That's it? That's the way it's been lately, huh? All right, one more. Promise, this is the last one. That one. Let's talk about what's happening at 0. I'll take a volunteer. If you've already said something, then you can't play. New volunteer. F of 0. What's your name? Okay, Nicholas. There you are. Okay, F of 0?
Yeah, undefined.
Undefined, right? Undefined. Do you want to keep going?
Yeah.
Okay, what's the limit? How about this?
Should be infinity, right?
Should be infinity. That means you had to check from both sides, right? So from the left, what was it? Infinity. And from the right? Infinity. So this answer is infinity. We checked both sides, right? Good. All right, I think you get it. I think you do. Okay. This is a good time for a break.
Wait,
Yes. Yeah.
it was one that was also negative.
Okay, so that would be does not exist. Is that what, okay, so like that one where it was doing that crazy stuff from both sides, if I said what's the limit as x approaches 0, you would say does not exist. Good. Yeah, I think this is a good natural place to take a quick break. Let's say we do, you want like 5 minutes? Yeah? Let's go for 5. You don't have to leave, but you can. I'm going to step out for just a minute because my phone's been just vibrating in my pocket for a while. You can stay on your phones for a second. I've got something to do real quick. All right, I think I'm ready. So this is our final kind of definition of the limit. So it says here, suppose we have a function that is defined near some value, so like near 2. Then we write limit x approaches a of f of x equals L. So you know how we've been getting answers? That L right there is the number that we're approaching. We will write that and we will say the limit as x approaches a of f of x equals L if we can make the values of f of x arbitrarily close to L. That just means the closer we get to that x, to the, like 2, the closer our function gets to that value, like 8. So this is like the 2 and this is like the 8 in our first example. All right, now what we're going to do, up to this point, I've given you the drawing, right? And I've said, hey, go find these limits. Look from the left, look from the right. Now, I'm going to give you some information about a function. And I'm going to ask you to draw me the function. So it's going to be reversed. I provide you the information about the limits. You come up with a picture of this function that has these characteristics. So I'm trying to draw a single function that satisfies all of these at the same time. All right? There's going to be a lot more thinking involved in this. All right? So let me start by drawing my xy. And what I like to do is I like to start by looking at things that are easy. All of these conditions have to be satisfied. The easy ones are the ones that are algebra. Like number 2. It's saying that when I plug -2 into the function, I should get 0, right? That means if I go to the left 2, right, x is -2, it should spit out a point 0. Do y'all agree that that's this one right here? Right. The next easy thing, I guess, for me to see here is that f of 1 has to be 2. That means when I go to the right 1, I should go up 2 and draw a dot. So just by number 2 and number 5, I know that these 2 points live on my picture, right? For sure. All right, the rest of these, oh well, this one right here says f of 4 is undefined. That's algebra, isn't it? That just means that at 4, 2, 3, 4, there's no picture, right? Maybe it's a hole, I don't know. But there should just be no picture here, right? I think I'm going to have to just remember that when I go to draw this. All right, so I'm going to leave this kind of as a question mark because I don't think I've completely satisfied that condition yet. We'll see. All right, let's go start talking about limits. This part 1 says to us, Aaron, where's Aaron? Aaron, okay. Aaron, what is the first condition saying to us? From the limit as x approaches what number? What number are we approaching? -2. From which side?
Actually,
both sides, right? This is saying that when we approach -2 from both sides, our function has to be headed towards what? 3, right? So that means here's 3, right? Here's 3. I know that when I approach -2, right? -2, which is here. When I approach that from the left and the right, I have to be headed up to that 3 up there, don't I? So I need to be headed towards here. I'm going to put an open circle here because I'm headed towards that, right? Why do I not fill that in with a solid dot? Because it's already defined to be this, isn't it? And if you put a dot here, then your function will fail the vertical line test from college algebra, and it will then no longer be a function. So you're not allowed to have 2 dots like that along a vertical line. So I'm going to put a circle there, and then all I know is that from both sides I'm headed towards that, right? So I'm just going to draw a little tail off the side here, and then just a little tail off this way. I don't even know what it looks like. Do you agree that from that picture, from the left and from the right, it's headed to 3? Right? Every one of our pictures is going to look a little bit different depending on how we draw it. That's the way I'm drawing it so far. That satisfies this first condition. Second one's already satisfied. Third condition. All right, who's up? Grant? Okay, Grant, everything going okay? Okay, Grant, what is this one saying?
as you approach 1 from the left, you should be at -1.
You should be headed to -1, right? Okay, so that means when we approach 1 from the left-hand side, we should be headed to, you said -1? That means down here, right? And only from the left. So it should be coming in, I don't know, maybe like this, right? Someone else could have made it come in this way. Everyone's going to have something different. Grant, what should we put right here? Open circle. Because that's already filled in. Good. Any questions? All right, Stephanie. Oh, there you are. Make sure there's not one. All right. What is this one saying?
As the limit approaches 1, x is 2.
So which way are we approaching 1 from?
To the right.
From the right. And then our value should be approaching 2, right? So the height should be 2. So we're approaching 1, right? From the right. And we should be headed up to 2, right? So I don't know, do you want me to come in from the top or the bottom or sideways? Do you care? No? Okay, so I'm gonna do it this way. There we go. And then what do we put there? Well, it's already filled in, isn't it? It's 2. So I'm headed into that point. Y'all seen this? Okay. Condition 6, we've already satisfied 5. 6 is going to go to Jorge. Okay. What is this saying?
It's gonna approach 4 from the left.
4 from the left, and we should be headed where? Ooh, okay. So, pardon me? So if I come in, here's 4, right? And I'm coming in from the left, and where should I be headed? Infinity. So it's going to go like that, right? Like this. The thing is, at 4, it's what? Undefined, right? So I'm not make sure I don't cross over that. So it's a vertical asymptote from college algebra. This is a vertical asymptote right here. All right, good, Jorge. Let's see. Who's up? Jennifer. Hi, Jennifer.
I go by Jenny.
Jenny, okay. Jenny. Yeah, y'all just let me know. I'll try not to mess it up. J-E-N-J-E-N-N-Y. Okay. All right, Jenny. Do you understand this, what this is asking for here?
Number 7.
Okay.
As it approaches 4 from the right.
4 from the right, we're headed to 0. Okay, let's try that. So we're approaching 4. Here's 4. From the right, we're headed towards 0 on the y, right? Which is the x-axis, isn't it? So I'm headed towards it like I could come in like this or like that, any way I want, right? Does that make sense? No? We're headed towards 0, right? 0 is the up and down. So as I approach 4 from this side, I should be headed to 0. Okay? So I'm going to come in, I'll come in this way. Like that. Now, what happens at that point 4? It's undefined, right? So I'm going to put a circle here. I'm headed towards 0, but I'm never actually getting there. Does that make sense, Jenny? Everybody? Have I satisfied all the conditions? Yeah? Satisfied them. Now, the problem with what I have right now is that it's just a bunch of pieces. Now what I need to do is connect everything together, and this is where we're all going to have some freedom as to what our graph's going to look like. So we're going to connect everything together. We're going to make sure that at the end we have a function, which means it must pass the vertical line test. So here's the way I'm going to do. I'm going to do the easy parts first. I think they're easy. Remember this little tail that came out here? Do you see that I have another tail here? I'm going to connect those together. All right. And then I had this little tail here, and then I had this thing, right? Why don't we just make some crazy shit in there first? Just because I wanted to, right? I have that freedom to do what I want there. Just make sure it's passing the vertical line test, right? And other than that, it's pretty much done, except I've got this doing this, and I get to do what I want here. So I'm going to do this just because I want to. Make it go down like that. I could do whatever I want. And then this one right here, I'm going to make this one go down as well. Put a little arrow on it. I could have even drawn it and stopped it. It doesn't matter. That function, right, past the vertical line test, that is a function, and it satisfies all 8 of these conditions. Do y'all see how our pictures might look different? Like yours might look a little different than mine, but we should all have the same 8 characteristics on that graph. We good? Yes?
Go over
Number 3. Okay, so we were approaching 1, right? So 1 on the x. Here's 1. We're approaching it from the left-hand side because of the negative, and we need to be headed to a y value. Remember, this is always your y value. We're headed to a y value of -1. Here's -1 here. So as we approach 1 from the left, our graph needs to come down towards -1.
And, okay, so the other one was at 2.
Yeah, so the other one was from the right. We need to be going up towards 2. So we came up to 2. And it just turned out that this one was already filled in because of, which one was it? 5 told us to fill that in with a solid dot. Good? All right. I like to give problems like that on a quiz, right? I like to give one problem where first I give you a picture and I ask you for the limits. And then the second question would be, here's some conditions, draw me a picture. Those are always a good first quiz because it shows that you understand both concepts. Good? Hint, 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 hint. All right, we're done with 1.3. And it's 3:12. So an hour, 15 minutes left to see how far we can get into 1.4. Everything we've done so far has been very visual, right? Very visual. And limits are, for the most part, pretty straightforward when you have pictures to go with. What we're going to do in 1.4 is we're going to see if there's a way that we can find the limit of a function purely algebraically, all right? Instead of looking at a graph.